Ever wondered how applications like Amazon, Netflix, or Epic Games remember where you left off? Like your place in an online game or items in your shopping cart? That's the magic of stateful architecture, a design where your interactions persist across sessions. This makes user experience smoother and more personalized. In this video, let's dive into some common techniques to manage state effectively. There are ample real world examples and a bit of Java code included to make it simple to understand. So, let's get started. Hi there, welcome to Tech and Career Bytes. I'm a software professional with over 2 decades of experience, including 7 years in leadership roles at a global product based organization. Stateful systems are crucial in scenarios where user data needs to stick around. Think of online banking or e commerce. The system remembers who we are, what we are doing, and what we have done, ensuring continuity and ease of use. We have a separate video explaining in detail stateful and stateless architectures. If you want to know more, please watch that. The link is available in the description box. Our focus in this video is on common techniques to manage state effectively. Now, let's dive into some common techniques to manage state effectively. I have included some Java code examples to help us understand better. However, it's important to note that while Java is powerful, it might not always be the best tool for every situation. Our first technique, using session cookies. Session cookies are fundamental to many web applications. They store small pieces of data like a session ID in our browser's memory. This idea allows the server to retrieve session information for each user. For example, imagine you are shopping on Amazon. Session cookies help keep track of the items in your cart, ensuring they remain there as you continue browsing the site. If you are curious to see what session IDs are stored in your browser, you can usually find them in the browser's developer tools under cookies. Here is a simple Java code demonstrating session cookies. Token based authentication, particularly using JSON Web Tokens or JWTs, is a method to manage user sessions without requiring the server to store session data. For example, Netflix uses JWTs to manage sessions across its vast network of microservices, ensuring smooth streaming experiences for its users. A JWT consists of three parts: the encoded header, encoded payload, and the signature. These parts are separated by dots. JWT encoding is typically done using base64 URL encoding. Base64 URL encoding is a variant of base64 encoding. The header specifies the token type and the signing algorithm used. The payload contains claims relevant to the user's session. For Netflix, this might include user ID, subscription level, and permissions. The signature is generated by first combining the encoded header and the encoded payload. After this combination, the HMAC SHA-256 algorithm using a secret key is applied to produce the final signature. Combining all three parts, the complete JWT structure would be this. And the encoded JWT is shown here. When a user logs in, the server creates a token containing user identity and permissions, then sends it to the browser. The browser stores this token and includes it in future requests to authenticate the user. The server verifies the token on each request to ensure it is valid and grants access based on the encoded information. Here is a simple Java program for creating and reading JWT using the Java library JSON Web Token. Now, on to our third technique, in-memory caching. The session cookie is just a way to link a user's browser with the session storage on the server, where the actual state data is maintained. In typical web applications, state management requires both session cookies and session storage, whether in-memory caching or database persistence. For Faster data retrieval, session data can be stored in memory using tools like Redis. This approach is similar to keeping data in a super fast temporary storage area. For example, Twitter leverages in-memory caching to handle massive user traffic efficiently. Here is a sample Java code snippet for persisting and retrieving session data in memory. Sometimes we need to store session data in a database for durability, making it available even if our application restarts. For example, banks store session data in databases to ensure transaction continuity and data integrity. You can see here a sample code snippet for persisting session data in databases. In a load balanced setup, sticky sessions ensure that a user's requests always go to the same server. This keeps their session data consistent so the server can easily manage their session as they use the application. When a user interacts with the application, the server saves their session data like preferences or login status in memory or a session store. This helps deliver a smooth experience as the user continues to browse or use the application. For example, AWS uses sticky sessions in its load balancers to maintain session consistency for users during their interactions. You can see a code snippet here to enable sticky sessions. The challenge with sticky sessions is that they create a single point of failure. In distributed systems, the session state is replicated across multiple servers to ensure high availability. This way, if one server goes down, the other can take over, preventing disruption of the user's session. For example, online multiplayer games replicate player states to ensure the game continues smoothly even if a server fails. The code snippet here creates a Hazelcast instance, stores the session value in a distributed map, and then retrieves that value. For those who don't know, Hazelcast is a distributed caching solution. Our last state management technique, event sourcing. Event sourcing tracks every change to an application state as a series of events. This approach lets us rebuild the state by replaying events, which creates an audit trail and allows us to roll back changes if needed. For example, financial systems use event sourcing to ensure accurate tracking of account balances and to enable auditing of transactions. A possible series of events are listed here. These events can be replayed to reconstruct the current state of the account, track historical changes, and ensure accurate auditing of transactions. Stateful architecture is the backbone of seamless and personalized user experiences in today's digital world. By mastering techniques like session cookies, JWTs, caching, and event sourcing, we can build robust applications that keep users happy and engaged. If you found this video helpful, give us a thumbs up and subscribe to our channel for more interesting tech topics. Do check out our other videos on software performance optimization case studies, coding, system design, big data, and career growth. My name is Rupa and I thank you so much for watching this video. See you next time.